So this is 6.2a in college algebra. In 6.1 we did some gnarly stuff with parabolas, and today we're going to do some things with circles and ellipses. Okay, some real quick review as far as the ellipse is or the circle is concerned. A circle is the set of all points equidistant from a point here called the center. So this is called the radius. And notice that when the circle is not sitting on the origin, we call the point the center point HK. So we went over H down K. And that gave us this point here. So it is offset over H down K from the origin of the circle. And there's a point XY. There's a point XY anywhere on there that is R away. And one of the things I'm going to show you is, first of all, x squared plus y squared equals r squared. That's the formula for a circle with the radius, or with the center on the origin. Alright, the formula when the center is not on the origin is basically the same Okay, so see what happens here? When the center point is on the origin, h and k are 0, 0. So x minus 0, or just x squared, plus y minus 0, or just y squared. So that's why we say this is on the center of the circle is on the origin, because h and k are both 0, so they go away, and it's just x squared plus y squared equals r squared. But when the center point is not on the origin, we use this formula right here. Alright, so what we're going to do is get rid of this formula because we don't really care about it, and we're going to use this one. And let me get rid of this and pull up example 1. Alright, so here is the formula for this circle here, and what they want us to do is they want us to find the circle, or they want us to find the center and the radius, and they want us to graph then the circle, which that's what the graph of the circle looks like. But let's pretend like we don't have that. Alright, so we have x squared plus y squared minus 16x plus 14y plus 32 equals 0. Alright, so there's a few steps here that we're going to do. We are going to, because we have an x squared and a y squared, that is telling us that we need to complete the square. But since we have an x squared and a y squared, we have to complete the square twice. So what we're going to do is we're going to put the x's together and the y's together, and we're going to move the constant to the other side. Okay, till we get that. Now what we're going to do is we are going to complete the square of the x portion of it. Half of 16 is 8, squared is 64, and we're going to complete the square for the y part. Half of 14 is 7, squared is 49. Now because we added 64 to the left side and 49 to the left side, we also have to add it to the right side in order to make it continue equal. So we've got this x minus, which is that sign there, square root of 64, plus y, the sign here, plus square root of 49 equals 81, the sum of all those. Okay, not too hard. Now it has to be in this form. This has a minus sign, this has a minus sign, this has a minus sign, that has a plus sign, which means we have to change that. So x minus 8, y minus negative 7. So there we have our minus sign, and right there. And the reason we do that is because if you don't, you're going to look at this and go, oh, k is 7. And no, k is actually negative 7. All right, so what I'm going to do here is I'm going to write what I've got. I have h equals 8, not negative 8. It equals whatever h is. And k equals negative 7. And the radius then equals the square root of that. See, r squared is 81, so r must be 9. And what do we have here? We've got our radius at 8, negative 7, or our center point at 8, negative 7, and our radius then is at 9, exactly how we want it. And that's pretty much all there is to circles. We're done there. All right, so let's go on to ellipses. Okay, so here's an ellipse. And an ellipse is the set of all points, so this red here, a set of all points in a plane, the sum of whose distances from two fixed points, the foci, here and here, is constant. So what that means is, if we have a point here, and we take this distance and this distance and add them up, so let's say that this is 6 and this is 3. And then I take another point here and take this length and this length and add them up. This might be 7 and this will be 2. But no matter what, the sum of this length and this length will always be the same as the sum of this length plus this length, or any point on the circle. If you add the two distances from the foci up, they will be the same. So that's the definition. Now let's look at a couple things we've got here. This distance from here to here, so the long part from vertex to vertex, is the major axis. And the distance from there to there, from here to here, can you guess? It's going to be the minor axis. And this ellipse can be this way or this way. Doesn't necessarily have to be just this way. All right, what else do we have? We have the y-intercepts right here and right here, which are, and the major intercepts are there and there. And notice the major is always longer than the minor. Let's see, anything else with that? I don't think so. So let's go ahead and start plugging away at doing some stuff here. So let me bring this part of page 537 up, and this gives us our information. All right, so notice a couple things here. Here's the formula for an ellipse, and here's the formula. Now notice when x squared is over a squared, that means that it's going to be horizontal, because the a squared is the major axis. So a is the major axis, b is the minor. So what this is saying is that on the x axis here, a is the major axis. Now on the y axis, b is the minor axis. Okay, so a is the major, b is the minor, always. Okay, now watch what happens here. When we get one that's turned over, x is over b. What does b mean? B means minor, so it's the smaller one, and a is the bigger, so it's going to be flipped over so that the y value is going to be the bigger one, and up here the x value is the bigger. So that's one way to tell. Look and see which letter, x or y, is the a under, because the a will tell you, oh, x is the major axis. A is here. Oh, y is the major axis. Okay, so that'll just tell you if it's up or down or this way. And the book doesn't say that, so sometimes it's a little tricky to figure all that out. The vertices are negative a0, a0, so that gives you an idea. We're just going to look at 4 points here to find when we solve these. And it says solve for such and such an equation and then graph. We need these 4 points here. And then we can just draw a nice smooth circle here and be done. So the vertices are at negative a, 0, and a0. So that'll tell you where that point is and that point is. The y-intercept will be up here and down here where it crosses the y-axis. So you're going to have to find b. So you're going to find a, going to have to find b, and you're going to have to find c because that's the foci. The foci is going to be at negative c and positive c, 0. Okay? So then the same with these. You know, you're finding the same thing. The vertices, but the x-intercepts instead of the y because it's this way, and the foci. And you also use these equations usually in order to find a, b, or c. Okay, so that information, let's go ahead and do example number 2. If I can get a pen working here. Okay, so find the standard equation of the ellipse with vertices at negative 5, 0, and 5, 0, and the foci is at negative 3, 0, and 3, 0, and then graph. So we're looking for the equation in this form right there. So because the vertex is at negative 5, 0, and 5, 0, I know it's going to be a graph that looks like that because the vertex is on the x-axis. If it was on the y-axis, it would be this shape right here. Alright, so how do we do this? We're trying to get this in this form right there. So that's what we're trying to get it to look like. Since the vertices are negative 5, 0, and 5, 0, and the foci are negative 3, 0, and 3, 0, we know that A is 5 and C is 3. Okay, because we've got the foci and we want this length here. Okay, and the vertex will always be longer than the foci. Alright, so now we've got that, but we don't know what B is. Okay, because again, if you look at this equation, we have to know B right there. So we're going to use the formula right there. C squared equals A squared minus B squared in order to find B. So we're going to write this as 3 squared equals 5 squared minus B squared. So 9 equals 25 minus B squared. So B squared equals 16. So therefore B equals 4. So now I can write the formula. X squared over, it says here A squared. Well, what is A? A is 5. So that's going to be 5 squared. Formula, plus y squared over, what is b squared? 4 squared equals 1. So that's the formula, and it equals 1. So there is my formula. Now I can leave it like that, but probably need to go x squared over 25 plus y squared over 16 equals 1, and you're done. Okay, the only other thing that you need to do then is graph it. And graphing it is not too difficult because, let me get a XY axis. This one is on the origin because that's what we've learned to do so far. This formula here is when it is on the origin. We'll do some other ones that are not on the origin later. See, this says with center at the origin. Alright, so how can I graph this? Well, I know that my A, my major axis, is 5 and 5 this way, and my minor is 4, and my foci is at 3 and 3. Now the only reason you use the foci really as far as on these graphs is if you're trying to get a real accurate graph, these foci can help you to draw your graph more accurately. For this, what we're doing now, you don't really need to worry about that because we're just kind of making it look like that. But if you had instruments and you were trying to do it, you would set your compass here and draw this part, and then your compass here and draw this part, compass here and draw this part, and this part to make it really pretty, but we're not doing that. So anyway, end of this video, and we'll go with example 3 on the next one.